Okay, so let's take a look at number of intersections and solutions. So remember, we graphed the line back in grade 10, y equals mx plus b, and we graphed the parabola this year earlier. So for example, on the left, we might have no solution, where the parabola doesn't quite hit the line, or down below, the parabola doesn't hit the parabola, or the parabola on the inside is so steep that it never hits the parabola on the outside. And some other versions. Okay, off to the right, the middle column. One solution where the parabola hits the graph at one tiny little point. Or an upwards parabola hits a downwards parabola at one point. Or they're exactly the same shape and they'll never hit again. So they only hit at one point, and there's others probably. And then off the right, two solutions. So a parabola hitting the line twice. Or an upwards parabola hitting a downwards parabola. Or some other version that you can figure out. One solution, no solution, two solution, one, no, one, two solutions. So if you remember last year, we graphed systems of equations. We graphed lines where they intersect, and they sometimes had one solution. If they were parallel, no solutions. Oh, I forgot infinite solutions on this page. Infinite solutions if they're exactly the same. So, no solution, one solution. Now we're seeing two solutions. And obviously, keep in mind, you might have a graph that has more or less than these cases. More, excuse me. Okay, so that's number of intersections. Remember, we can graph these things from last year. Y equals mx plus b. Slope-intercept form, slope-point form, general form, whichever. And we have parabolas and how we can graph them and all their different features. We have to remember that we're going to be using all of the principles that we've been doing so far as we move forward. So now let's take a look at some algebraic examples.